Good evening, everyone. I'd like to welcome you back to the Planetarium here in Berlin, part of the Stiftung Planetarium Berlin. Tonight's live stream is going to be another Starry Night. That's our English language program. So we'll be doing the entire show in English this evening. I will be your guide through the night sky and space this evening. My name's Anna Green, and with me today for the Technic, I have Dennis flying around the universe for me this evening. I have Stefan, and Janina will be engaging with you in the live chat on YouTube. So normally, you can see I'm in an empty dome here, but normally we would use the projector that's behind me, our Universarium. But this evening we'll be using entirely our digital system to reach you in your homes. So at this point, we're going to get into the good stuff. So I would invite you to sit back, relax, and enjoy as we head to 10:30 p.m. this evening. So we have a lot of exciting stuff in our sky this evening, and it's now past civil twilight at 10:30 p.m. The sun and its light is gone. It's dark enough to start seeing some stars and getting our bearing on our summer night sky so that we can start with observing possibly the most exciting thing that we have in our sky right now, which is a comet. So right now, we have the ability to see a comet. Its full name is Comet C/2020 F3 Neowise, and or Neowise for short. And this comet, we're not going to be able to see it again in our lifetime. So it has an orbital period of 6,800 years. So if you'd like to see it, now is the time. And to find it, you're going to need a somewhat clear view of the horizon, but over the next few days it should, or it'll get a little bit higher. And what you want to do is use the Big Dipper. So you want to orient yourself towards the northwest. And you can see the Big Dipper there outlined. Here in Germany, we call it der große Wagen. And you're going to follow the two bottom stars of the Big Dipper, Figda and Merak. And you're going to draw a line down towards the northern horizon. And unfortunately, I can't put a point in the sky for you, but it's about halfway between the Big Dipper and the end that you're seeing, marking north. And that's where you will be able to see Comet Neowise. And right now, it's currently at a magnitude of about 3. So that's how bright it is. So anything that's above 6, we really can't see with our eyes anymore. And as the numbers get lower, the better we see it. So fortunately for us, even in city skies, and even when the sun's out a little bit, we can still see this comet. And it's actually really cool to see it over Berlin. And we're going to take a look at a video now that my colleague Stefan took. So this is Comet Neowise over Berlin. You can see the tail really well, and even with how bright it is in Berlin and flashing lights and all of the light pollution that comes from being in a city, you can still see that comet really well. So definitely take the opportunity to go outside and check it out. Unfortunately, I know here in Berlin it's been cloudy for the last week, 2 weeks, so it's been kind of hard, but if you notice that the clouds are gone, definitely go out. It's worth going and taking a look at this comet. It's really cool. Now, Neowise is not the only comet that we have in our sky. So we are going to also take a look at a comet C/2019 U6, or also known as Lemon. And this comet, we're going to shift our skies a little bit more towards our setting springtime sky. So we're going to look more towards the west. And as we travel towards the west, you're going to see Leo the lion there and Virgo the maiden of the harvest. And if we look at Leo's tail, we're going to see a star there called Denebola. And if you go between that and the star that is in Virgo's arm, kind of kind of near her elbow, about halfway between those two, that's where you'll be able to find Comet Lemon. Now, I should tell you that Comet Lemon is not nearly as bright as Neowise, and so you're going to need binoculars or a telescope to see that, and it too will be getting dimmer as the days go on and it moves farther away from the sun and the Earth. But if you have a pair of even pretty simple binoculars, you should be able to go out and spot it over the next couple of days. So now that we are looking towards the western sky, maybe we'll head a little bit more towards the southwest so that we can take a look really quick at our summertime sky so that we can see the constellations that are out now since it is summertime. I know we've been having a really mild summer here in Berlin, but the stars will never lie to you about what season it is, even if the temperature doesn't quite match up. So in our summertime sky, the best way to orient yourself is to look for the summer triangle. And the summer triangle, as you might guess, is made up of 3 bright stars. Oftentimes, children tell me it looks like an empty ice cream cone, so you can think in summertime I need to look for the ice cream cone. And our summer triangle is made up of 3 stars, Vega, which is in Lyra the harp, Deneb, which is the tail of Cygnus the swan, and then finally Altair, which is in Aquila the eagle. And so these 3 constellations are attached to this asterism of the summer triangle. And so if you can find that summer triangle, that'll give you a good look at where we are in our summertime sky. That's also going to help you find something else that you may want to observe. And so if you follow the summer triangle, it's pointing down towards the south. And if you follow it down, you're going to be able to find 2 planets. Now, sometimes it's a little hard to tell if what you're looking at is a planet or a star. So there's a couple ways that you can make sure that you know what you're looking at is a planet. So the first way may sound a little silly, but if any of you have ever sung the song Twinkle, Twinkle, Little Star, that is how we do what we call the Twinkle test. So as the song tells us, it's not just a nursery rhyme, it was probably all of our first astronomy lesson. And the song simply tells us that stars twinkle, they scintillate. Planets, on the other hand, do not appear to twinkle. And so if the object you're looking at is stationary, it's not moving slowly through the sky, and it's not twinkling, then what you found is most likely a planet. And a way to double check this is to see where it is in the sky. So all of the planets will appear in what's called the plane of the ecliptic. And what marks the plane of the ecliptic is the zodiac. So you can see the ecliptic is on the screen now, and Jupiter and Saturn are right on that. So the ecliptic, or the plane of the ecliptic, is the path that the sun, the moon, and the planets all appear to take through our sky. But obviously, we don't have the luxury of a line designating that for us in the real sky, so you can find that with the Zodiac constellations. And Zodiac, we often think of that as being involved with horoscopes and astrology, and if that's something that you enjoy, that's totally fine. But here in the planetarium, we look at astronomy, the science of the stars and outer space. And so a good way to look at these constellations is to look at them from the astronomy point of view. So Zodiac, you can think of the word zoo. It means a circle of animals. And almost all of the constellations in the zodiac that you see are animals. And so that was just what ancient astronomers looked at and were able to see and predict where the planets would appear. Now, if we move to 3:30 a.m., which I believe we have already done, you're going to be able to spot a couple more planets. So if you are a night owl and you're willing to stay up, or if you're an early riser, you'll be able to spot Mars, which we can see now in our sky. Mars is going to come out just after midnight. And you can tell it's Mars because not only will it not twinkle, not only will it be in the zodiac, but you'll also find that it has kind of a reddish tint to it. So all of the other planets will look whitish, but Mars, our red planet, will look more red. Now, Venus is also going to be up in our sky, and it rises around 2:30 a.m. And you can already see that there's a little bit of, or a lot of light on our horizon. The sun is just about to rise. And so if you look just above the eastern horizon, you'll see Venus. But I would like to caution you, please be very, very careful when you do this to make sure that you don't look at the sun. We never want to look directly at the sun. It can seriously damage your eyes, your vision. So again, when looking for objects that might be near the sun, please, please, please be very careful with your eyes. Now, what we have looked at so far, it doesn't really represent what we see here in Berlin. You've probably noticed that you see way more stars with the planetarium than you do in the real night sky. And simply put, that's because Berlin, like most major cities, suffers from light pollution. And so we see far fewer stars, just the brightest ones, and fortunately, Comet Neowise. And if you noticed in that video that we looked at just a little bit earlier, you can see it again. Again, you can really see how bad the light pollution is here. Neowise is really the only thing that we're able to see in this video. You can make out the Big Dipper here in Berlin, and a couple other brighter patterns of stars, but unfortunately, that's really what we have. Now, we have left the Earth to take a look at our home planet from above. And if we head to look over Europe, we'll see that it is in night, and you're going to see just how bad the light pollution really is when we see the Earth at night. You're actually going to be able to tell which cities are where based on how big the appearance of the lights are. So we can see in Australia already where some of the bigger cities and the population really lie, and also in Asia. You can see most of Japan is just light. And as we head further towards Europe, we will be able to see pretty easily where Berlin is, as well as Paris and a few other. Oh, we're already in daylight, so I spoke falsely. But we are going to use the magic of the planetarium to travel back in time so that we can show you just how stark that light pollution really is. And you're also going to be able to see, though, that we do have some spots where you don't really see lights in Germany. They're getting fewer and harder to find, but they are there. And so now that we have Germany at night, we can zoom in on where we find Berlin. They're northeastern in Germany, and it's really quite a bright spot on our map. So the bright spot that you're seeing first and foremost there is Paris, and then if we keep going, you're going to see some clusters of lights, and that's Berlin. Now, like I said, you're going to notice some darker areas, and in those darker areas are where you're going to have better stargazing. And you might be wondering, well, where can I go near Berlin to find a better sky? I want to see a clearer sky with more stars. You have to go about an hour and a half away by car, so it's about 70 kilometers. And there is actually an International Dark Sky Association dark sky site. So what that means is that it is actually protected and will remain dark, and it's called the Sternpark Westhaveland. And so you can go there, and that literally translates to Star Park. And so you can go there and quite easily enjoy a beautiful starry night when we don't have a cloudy sky, of course. Now, we talked already a little bit about seeing the planets in our night sky, but the best part about the planetarium is that we can go visit them in person. And so our first stop will be the first planet that's up in the evening, and that is Jupiter. So we are going to have to travel quite a ways. Jupiter lies about 778 million kilometers or 484 million miles from the sun. And at this distance, it takes sunlight 43 minutes to travel to Jupiter. And by comparison, Earth is an average distance from the sun of 93 million miles or 150 million kilometers, and it only takes light 8 minutes to reach the Earth. So we can see that Jupiter is really quite far away. And now looking at Jupiter in its orbit around the sun, we can see that Jupiter is surrounded by many, many objects. So all of those white orbits that you're seeing are Jupiter's many moons. So Galileo Galilei discovered the first 4 largest moons over 3,000 years ago. Or sorry, 300 years ago. 3,000 would be really quite something. It was over 300 years ago. But since then, our technology has gotten better, and we now have 53 confirmed moons of Jupiter, 26 provisional, and that comes out to 79 moons total. And several of these were found just within the last couple of years. So again, as our optics, our technology gets better and better and better, the more that we're going to be able to learn about even our solar system, our home. So the 4 orbits that you're seeing now, those are the Galilean moons, so named because Galileo discovered them. So Io, Ganymede, Calypso, and Europa. Now, Jupiter is the largest planet in our solar system. So it has a diameter of 142,900 kilometers, about. Another way to look at that is that 11 Earths would fit across it. And you can also think of it if Earth were a 5-cent euro coin or an American or a Canadian nickel, then the size of Jupiter would be about as big as a basketball. So if you want to test that out at home, you can, just to get a good idea of how much bigger Jupiter is. And in fact, it's so big that all of the other planets in the solar system could fit inside of it with plenty of room to spare. Now, despite being the largest planet, it has the shortest day in the entire solar system. It lasts just 9.93 Earth hours, so about 10 hours. And 1 year on Jupiter is almost 12 Earth years. Now, one of the really cool things about Jupiter, especially within the last few years, we've found, thanks to the Juno satellite that we sent there, we've gotten some really beautiful images of Saturn back, of its storms, of course, the Great Red Spot, and all of the other storms that we see pop up, and the way the clouds whirl and swirl. So these stripes that we see on Jupiter and the swirls, they are actually cold, windy clouds of ammonia and water. And they're floating in an atmosphere of hydrogen and helium. And basically, Jupiter took the leftover material from the sun, the hydrogen and the helium, and it stole it in its own makeup. But Jupiter never got quite massive enough that it was able to ignite and become a star itself. And so that's how we have our beautiful gas giant Jupiter. Now, Jupiter has a very, very, very small ring. It's very hard to see, and in most images we don't see it. But I think that between the Great Red Spot and these beautiful swirling clouds that we see, that's really, really all that we need. Now, if we want to look at rings, then we have to go a little bit farther to the next planet in our solar system, which is Saturn. So all of the planets are named after Roman gods and goddesses. Jupiter is, of course, the king of the gods, and analogous to the Greek Zeus. Saturn was the Roman god of agriculture and wealth, and also the father of Jupiter. Now, Saturn is about 886 million miles or 1.4 billion kilometers from the sun. and it takes light 10 times as long as it does to get to Earth to get to Saturn. So about 80 minutes for light to reach Saturn from the sun. Now, the radius of Saturn is the radius of Saturn is about 58,000 kilometers, and Saturn is 9 times wider than the Earth. So if, once again, Earth was a 5-cent euro piece, or the size of an American or Canadian nickel, then Saturn would be about as big as a volleyball. So if you have a volleyball lying around too, you can add that to your solar system. And like Jupiter, Saturn is also made almost entirely out of hydrogen and helium. Now, what's cool about Saturn is, for the longest time, Jupiter reigned as king of the most moons. But recently, Saturn beat it out. So Saturn has 53 confirmed moons, 29 provisional, so they were found more recently, for a total of 82 moons around orbiting it. And here we can see Saturn's beautiful, beautiful rings. So these rings are complex, massy, icy objects. And it's thought that they're either pieces of comets or asteroids, shattered moons that broke up, and then Saturn pulled them towards it, and then with powerful gravity, of course, it forced these things to fly apart, it tore them apart, and that's what created the rings. And because of this, their rings range in size from, or the parts that make up the ring range in size from teeny tiny chunks of ice and rock, small as dust, to chunks that are as big as a house or even a mountain. So we really have a lot of variety there. And each ring orbits the planet at a different speed. Now, Saturn's ring system extends 282,000 kilometers from the planet. But the vertical height of these rings is typically only about 10 meters, so as tall as ceilings in some apartments, or buildings rather. And those are the main rings. Now, as we can see here, we're seeing those pieces of ice and rock that are floating along. So for us at the Earth, if we look through one of our smaller telescopes, we can see the rings, but not with much detail. We have seen beautiful images of the rings that have come back from probes that have been sent out over the years. But here in this rendering, we get to see them in much more detail, and it really is just a debris field when you're up close. Now, what's cool is that in these rings, if you go farther out, there's one very faint last ring, and there's actually a moon inside of that ring called Phoebe. And so Phoebe actually orbits within one of the rings of Saturn. Now, a day on Saturn, it's just a little bit longer than on Jupiter. It's only about 10.7 hours, and a year is 29 Earth years, so a little bit longer there. But we often talk quite a bit about Jupiter and Saturn, and we have a couple more planets that are further out. And so I would like to take you now to Uranus. So Uranus is about an average distance of 1.8 billion miles, or 2.9 billion kilometers, away from the sun. And at this distance, it takes sunlight 2 hours and 40 minutes to reach Uranus from the sun. And Uranus, I know, is the butt of so many jokes, but it's named after the Greek god of the sky. So typically it's pronounced Uranus, and that's how it's also pronounced in Germany. I've also, of course, heard it pronounced Uranus. And then, of course, also Uranus. So whichever version you wish to use, it's totally fine. So Uranus has the third largest diameter in our solar system. Its radius is about 25,000 kilometers. And it's 4 times wider than the Earth. So using our analogy with that 5-cent piece for the Earth, then Uranus would be about as big as a softball. And here we can see that Uranus has a ring, but the ring is not in the same position that it was for Saturn. So Uranus is pretty cool. Its axis is actually tilted so much that it looks like it's orbiting on its side. Its axis is tilted at 97.8 degrees from the plane of its orbit. And so it looks like it's just spinning on its side. And often it is referred to as the sideways planet. Now, its rings are also smaller than those of Saturn, of course. But it does have 13, so quite a few. Now, a day on Uranus is about 17 hours, Earth hours, and 84 Earth years makes up a year on Uranus. And it should be noted, often Uranus is referred to as a gas giant. And it's not really. That's not good. Not really the best way to classify it. And again, sorry for those of you who like to make the jokes. I know that makes it a little bit harder. But Uranus is really an ice giant, is a better way to classify it. And it's one of 2 in the solar system. The other is Neptune. And so what that means is that Uranus is about 80% or more of the planet's mass. It's made up of a hot, dense fluid of icy materials. So water, methane, ammonia. And then further in, it has a small rocky core. So, and it should be noted that all of these planets, whether it be Jupiter, Saturn, Uranus, or Neptune, often people think that we could have a spacecraft fly all the way through the planet, and that is just not possible. The pressure would crush the spacecraft far before it could come out the other side, and it would completely destroy it, which is actually something we did with Saturn. We had Cassini do a swan dive into the planet to get as much data as possible. Now, another cool thing about Uranus is that it rotates in the opposite direction from most of the other planets in the solar system. In fact, there's only one other planet that rotates in the opposite direction from the others, and that's Venus. So Uranus and Venus both rotate east to west instead of west to east. Now, as you can see, Uranus has this absolutely beautiful, beautiful bluish green color. And it gets that from the methane gas in its atmosphere. So much like we see a blue sky here on Earth because our atmosphere filters out the red, the same thing's going on with Uranus's atmosphere. So that methane gas in its atmosphere helps to filter out and absorb the red portion of the light. And so what we see is this beautiful green color. And then, of course, surrounded by these beautiful rings. Now, at the last Starry Night, we noticed that there was a request to learn more about Neptune. And so I'm really excited to go visit Neptune. It's actually one of my favorite planets. So we are going to travel now to 4.5 billion kilometers away from the sun. So that's about 2.8 billion miles. And out here, it takes sunlight 4 hours to travel to our next planet, to Neptune. And to put that, to give you an idea of just what the light situation on Neptune is, high noon on Neptune would seem like a dim twilight to us. So if you went out at dusk, that would be noon on Neptune. Now, Neptune is often thought of as a sister planet to Uranus. It is about 4 times wider than the Earth. And so if we were, again, using that same analogy, the 5-cent piece, then Neptune would be about as big as a baseball. So Neptune is not visible with the unaided eye. Uranus is really hard to see with the unaided eye, but if you have really good eyes, you might be able to spot it in a dark sky, but that's just impossible with Neptune. You have to have some kind of optical aid to see it. And because of this, it made it harder to discover. And so this was actually the first planet that was located purely through mathematical calculations. And so Urbain Le Verrier had this theory that there was a planet somewhere out there, and through mathematical calculations, he planned where it would be. And then another astronomer actually used these calculations to find it, and that was Johann Galle. And what I absolutely love about this is that he was based in Berlin when he found it. So we love to claim him as our own. So Neptune was discovered here in Berlin. I should also add that Galle actually found several things while he was here in Berlin. He also found a dark inner ring of Saturn and 3 comets. So lots of discoveries made from the observatory here in Berlin in the 1840s. Now, Neptune is named after the Roman god of the sea, which is what Le Verrier had hoped for. And so they honored his wishes. And so Neptune is the Roman god of the sea, and all of its moons were named for various lesser sea gods and nymphs in Greek mythology. A day on Neptune is 16 hours, Earth hours, and a year is 165 Earth years. And so since Neptune's discovery, we've actually only seen it complete an orbit one time. Now, of the giant planets, Neptune is actually the densest. So the least dense is Saturn. It could float in a bathtub. But Neptune is very, very dense, and it has the same makeup as Uranus, about 80% or more of that hot, dense, icy water, methane, ammonia, and a small rocky core. It doesn't have a solid surface. And again, its atmosphere is made up mostly of hydrogen, helium, and methane, and is quite large. It's quite a thick atmosphere, and it gradually merges into water, and then other melted ices, and then finally we get down to that solid core. And the core of Neptune is actually about the same mass as the Earth. Now, what's a little more interesting, and we haven't quite figured out why, is that you'll notice Neptune is a much deeper blue, very, very vivid. And if it has the same atmosphere as Uranus, you might be wondering, well why is Uranus more of a bluish green and Neptune is this very vivid blue? And what we haven't been able to figure out yet is what causes that more intense color. So we know that something else must be in the atmosphere that we don't know what it is yet. We haven't discovered that. So there's some unknown component there that makes that a much deeper blue. Another thing about Neptune is that it is the windiest planet in the entire solar system. So it has quite violent winds. And even though it's far, far away from the sun and it's the low energy input from the sun, Neptune's winds actually can be 3 times stronger than Jupiter's, which would make it 9 times stronger than the winds we have here on Earth. So just imagine the strongest wind you've ever felt here on the Earth multiplied by 9. Now, it's hard to see, but Neptune does have at least 5 rings. And what's interesting about the rings of Neptune is that they don't quite, or at least one of them doesn't quite act the way physics would tell you it would. So the ring that is farthest out on Neptune has these clumps of dust that are referred to as arcs, or ring arcs. And the laws of motion would predict that that dust should scatter evenly throughout the rings, but for some reason it's clumping together. And so the current theory is that there's a moon that also orbits just inward from this ring, called Galatea, and it's believed that it's the gravitational effect of this moon that is stabilizing these arcs in that outer ring and making them stay clumped together. Now, we've reached the end of our solar system, at least as far as planets go. Neptune is the 8th and final planet. And even though you're not here with me in the dome, I can hear some of you groaning and moaning about Pluto. We all love Pluto, but just a reminder, it's still in our solar system. We didn't kick it out. It's just been reclassified because we understand it better, and it is a dwarf planet. Now, as we zoom out, we're going to be able to get a good view of our solar system. And I'd like to do this because we're going to be able to get an idea of some of what that orbit of Comet Neowise is. So the lighter blue line that you see, a little bit faint, that is our comet. So that's the direction it came from. And then it is swinging around the sun right now, and it's going to fling back out into space. And periods of comets can change depending on what they interact with in space. And so what's interesting is that this comet moved faster before it reached us, and once it swung around the sun, its orbit has actually slowed down. So it's leaving the solar system slower than it came in. Now, the other comet we talked about, Comet Lemon, it had the opposite effect. So when it came in, it was moving slower, and leaving the solar system, it's going to be leaving faster. Now, as always, we don't want to leave you just hanging out in space. So we're going to fly back to our home planet, Earth. And as we do, we can see that beautiful tail from Comet Neowise streaking out. So when the comets fly past the sun, that is what causes these tails. And there's two tails. We just usually don't see the one unless we have really good sky conditions and really good optics. But these tails form as the comet starts to off-gas as it goes around the sun. It heats up and it starts losing parts of itself, and that's what creates this beautiful long tail. And as we fly back towards the Earth, it's good to always remember that the Earth is our home planet. There is no planet B. Earth is the only place at this point in time that we know of capable of sustaining life as we know it. And even if there are other planets out there in other galaxies or around other suns, they're too far away at this point with our technology to reach them. So the Earth is what we have. And we're going to fly past the moon here. That's what that red orbit is. And zone in on our beautiful blue marble. So this is home. This is what we know. This is what we have. And it's absolutely beautiful. And as you look at it from above, there's no borders. We see no borders. We just see the beauty of the Earth. And it's important that we take care of it, since that's what we have. And not only taking care of the Earth, but taking care of each other. Taking care of each other will also help us to ensure that we have a future on the Earth. So with that thought, I would just like to say that I hope you're all doing well out there. Again, please take care of each other. Take care of our Earth. And unfortunately with that, that's all the time that I'm going to get to have with you today. But I want to thank you so much for joining us. And I'm very, very excited to tell you that things are going pretty well here in Berlin. And so we are going to be able to reopen again on August 1st. So unfortunately, I won't be streaming into your homes anymore, which I appreciate you for inviting me in. But I can invite you to come join us live here at Planetarium, and then a little bit later at our other two locations as well, Planetarium am Insulana and the Aschenholz Sternwarte. So we really hope that you'll come join us. Of course, we'll be following the hygiene rules that the city has put forth and what the Robert Koch Institute is telling us is best to keep you all safe. So that is our utmost priority, is that you all stay safe. But I do hope that you will come join us. And that new schedule for our shows is on our website. So definitely check that out, and you can get your tickets right there on the website in advance. So with that, once again, I really want to thank you for joining us this evening, and I hope that you all stay happy, stay healthy, come visit us, and have a wonderful rest of your evening. Thank you.